This is Euclid Book 7, Proposition number 33, Part 3. And here is the diagram. I told you this diagram would get a lot bigger. Alright, let's go through this, shall we? I say next that they are the least that are in that ratio. For if E, F, and G are not the least of those which have the same ratio with A, B, and C, there will be numbers less than E, F, and G which are in the same ratio with A, B, and C. Let them be H, K, and L. Therefore, H measures A the same number of times that the numbers K and L measures the numbers B and C respectively. Now, as many times as H measures A, so many units let there be an M. Therefore, the numbers K and L also measure the numbers B and C respectively according to the units in M. So, in other words, H, which is 7, measures A, which is 42, 6 times. And 8 measures 48 6 times. And 15 measures 90 6 times. That's what that's saying. And since H measures A according to the units in M, therefore M also measures A according to the units in H. And this is by Euclid Book 7, Proposition number 16. So, 6 measures 42 7 times. 6 measures 42 7 times. That's what they're saying. For the same reason, M also measures the numbers B and C according to the units of the numbers K and L respectively. So, 6 measures 48 8 times, and 6 measures 90 15 times. Therefore, M measures A, B, and C. Now, since H measures Let me try that one more time. Now, since H measures A according to the units in M, therefore H, by multiplying M, has made A. And this is by Euclid Book 7, definition number 15. Which, if you take 7 and you multiply it by 6, you will get 42. For the same reason also, E, by multiplying D, has made A. Okay, so E, which is 14, if it multiplies 3, it makes 42. Therefore, the product of E and D is equal to the product of H and M, which we've established. Therefore, as E is to H, so is M is to D. Well, if E is 14, which it is, and H is 7, as 14 is to 7, so is 6 is to 3, which is true, because it's 2 over 1, which is also 2 over 1. Okay, and this is by Euclid Book 7, Proposition number 19. But E, in this case, is supposed to be greater than H. Okay. Well, in this case, actually it is. 14 is greater than 7, and 6 is greater than 2. And it measures A, B, and C, which is impossible, for by hypothesis, D is the greatest common measure of A, B, and C. Okay? If this was working in the right way, then D would be the greatest number that could measure A, B, and C. In this case, it's not. Therefore, there cannot be any numbers less than E, F, and G which are in the same ratio with A, B, and C. In other words, if we hadn't fixed the numbers, all this would have been impossible. Therefore, E, F, and G are in the least of those which have the same ratio with A, B, and C. And that's your whole proof. Alright, I will tell you more in a future video. Stay tuned.